Hello, this is Jeffrey Fox, continuing the Informatics course, and this is the final unit on cloud computing. Remember, we're not doing a very deep study of cloud computing here, just giving you a broad overview. There is a separate cloud computing course we recommend you take. As always, remember why clouds are important. They're the natural implementation vehicle to run data analytics collaboratively. You process big data and you solve problems in X informatics or digital X or E-X. Here we have 25 different values of X defined below, and as noted, there are probably more that should be defined. And here are the 25 different areas clipped from the web. Please, let's get some more defined. And the first set of slides describing data center architectures, both physically and also in detail, a little more detail in terms of the system structure. This slide here is a rather relatively old 2009 slide pointing out that cloud computing is like everything, it builds on previous approaches, of which probably utility computing is the nearest idea, but network computing, grid computing, and the need to use services are all important components of what drove the current cloud computing. This slide here points out that Amazon is making money. Namely, this estimate here says that in 2013, Macquarie Capital suggests that Amazon Web Services, which is the cloud part of Amazon, will get 3.8 billion in revenue, and that is up substantially from the 2.1 estimated in 2012. I don't think Amazon actually releases these numbers, they're just estimates, but it all suggests that this is a reasonably large field, and as it notes here, at the current rate, the Amazon Web Service business will be valued at around $19 billion, which is quite large. Here's a comment from an Amazon employee, and he thinks that clouds will replace company-owned data centers. If we look at the way that happens, you start off with your own basically computer center. That's a very traditional thing to do. Then you convert your own computer center to a cloud. That allows you to do server consolidation, and gain efficiency, and run the same number of applications on a smaller number of machines. Then you notice that there's not really it's not really your expertise to run computers, and therefore it makes sense to subcontract that to maybe one of these service companies like IBM Global Services, or eventually just ship the whole thing off to Amazon, who will provide the basic machines, system administration, storage, computing, networking, etc. And there is some controversy, of course, about security. Some people think that clouds are less secure than normal systems, others that they're more secure because you can actually run such systems in a highly professional fashion. And here we can get beta elasticity. When you want scaling, you get it. And some extreme fashion, you can say everybody could have a supercomputer. Of course, their credit card has to be able to pay for a supercomputer, but and everybody can get what they want with the elastic model of clouds. And this allows you to experiment quickly and find issues and not spend a lot of effort. You don't have to order machines, run your job, then find it doesn't work. And you can, of course, do big data on the clouds. One of the best examples is Netflix, which runs its very amazing service on Amazon. And it also, of course, clouds are very important for supporting the Internet of Things, and in particular smartphones, which are naturally associated with clouds. Here is actually a set. We have several slides from this talk, which I found a very good talk from Microsoft Architect, giving us a little more detail on actually how you build a cloud, which is pretty non-trivial. And these are the principles that you use in designing a cloud system, at least what Microsoft used. You have your virtualization, which uses the hypervisor to isolate the different applications. You have your virtualized network, which gives you security and isolation at the network level. You have a scale-out compute model with uniform nodes. Now, uniform nodes is possibly controversial, but as they point out, if you have a uniformity, then you can more easily expand in a easy fashion because every node is similar. Then if you want more nodes, you just twice as much computing, you just double the number of nodes. The next principle is that there is no permanent state on any node. So that's what it means by every node is a cache. The data is stored elsewhere, and the state of any node is externalized, namely it is stored outside the node. We have everything done automatically, operating system, hardware, application, their life cycle is managed in a scalable automatic fashion. And then everything is done with services, the platform as a service, software as a service. And of course, the hardware model is infrastructure as a service. But those are not the same type of services as platform as a service and software as a service, which are computer programs that act as services. They receive commands and data and give you out the results you ask for. So this slide from the Microsoft Architect points out the importance of scale and sharing. Scale is needed for several reasons. One is to actually offer cheap computing, because you will only offer cheap computing if you have a large system and you can share things like system admin and other types of support. You need a large system to give elasticity, so you can offer to any one user the ability to scale up their use on demand. And that requires that you share resources, because a given user will not have a uniform large usage model. And because we're sharing, we can actually increase the utilization of our system. So large shared systems allow lots of utilization, economies of scale, and elasticity. We need uniform systems, at least with current ways of doing management, because that allows the resources to be added and subtracted in a convenient, simple fashion. On a public cloud, we clearly need virtualization to get the necessary security isolation. However, we need more than virtualization, and we'll come across these extra things later on.